What use is an F-call? You've come across the term dB or decibel. Likely you've heard of dBi as well. These terms are all related to decibels, but mean completely different things. A decibel, named after Alexander Graham Bell, is a relative measure of two different power levels. That is, one power level compared to another power level. 3 dB is about twice as much power. 6 dB is about 4 times as much, and 10 dB is exactly 10 times as much power. This means that you can say that a feed line has a 6 dB loss. That is, you need to put 20 watt in at one end to get 5 watt out the other. In short, a dB is a ratio between two levels of power. In the feed line case, the power in versus the power out at the other end. In antenna land, you might have heard of dBi as the measure of amazingness of an antenna. A dBi is a measure of gain of an antenna when compared to an isotropic source. This is a theoretical reference that cannot actually exist in nature, but at least it's always the same, which allows you to compare two antennas to each other when their gain is both expressed in dBi. You might also come across a dBd, or an antenna gain when compared with a dipole. A dipole in itself can be compared to an isotrope. Its gain is 2.4 dBi, or 0 dBd, which incidentally goes to why many antenna manufacturers play silly games with dBi and dBd. An antenna described as 24 dB should send you back to the manufacturer to ask them 24 compared to what? If it's 24 dBi, it's compared to an isotrope. If it's 24 dBd, it's compared to a dipole. This means there could be a 4.81 dB difference between two incorrectly named 24 dB antennas. There's more than this. Think about dBw, dBv, dBu, dBmv, dBa, dBz, and many, many more. The thing to take away is that a dB is a relative term, one compared to another. If only one's specified, you don't necessarily know compared to what. dBi references it to an isotrope, and dBd references it to a dipole. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.